Hi again, welcome back. So you've just seen Dan in the lecture talk about the 7 steps of hypothesis testing. I want to follow up on that just a little bit and give you a little bit of a preview of what's coming up in the next modules and give you a little bit of help, sort of a little cheat sheet about something that you're about to encounter in all of the coming modules. So you saw in those steps for hypothesis testing that we're going to work through the same steps for the rest of the course. So one of the steps is writing hypotheses, another one is calculating a test statistic. So let me just show you, kind of preview the formulas that we're going to use. We have 3 main formulas that we use when we're testing significance. We have a T formula, a chi-square formula, and an F formula. And they all should look a little bit foreign to you at this point because we haven't covered them. But once we go through each module, you're going to see that they're actually not hard at all. They're just sort of plugging one number in, dividing by another, boom, you're done. There's just a little bit of work to work up to them. But each of these formulas is going to ask you to calculate a number. You plug in all these numbers, you get a result, and then decide if the result that you get is sort of good enough, or what we're going to call in this course significant, is significant enough to say that yes, indeed, there is a relationship between 2 variables, or if the difference between 2 groups is large enough to be significant. So each time you're going to calculate a number and then compare that number against something else to figure out if the thing that you found, the relationship you found, is significant. Okay, so what's that something else that you're going to compare things to? You're always going to have a calculated value. That's what comes out of these formulas. And the something else is called a critical value. We're going to find the critical value from a table because we have 3 different tests, chi-square, T, and ANOVA, or ANOVA is also called F. We have 3 different tables. We have a chi-square table, a T table, and an F table. So I want to walk you through the first one, and the first one first, obviously, chi-square, and then we'll move on to the T table and then move on to the F table. Now this, what you're seeing right now, is horrifying. You're never going to look at all of this all at once, right? We just put them all up here, just sort of a big summary that you can come back to if you need to during the course and kind of reorient yourself. What am I working on? What am I looking at? Sort of as this is your cheat sheet. Okay, so we're just going to block out the T table and ANOVA in your mind, and we're just going to start with the chi-square table. Now I want to tell you before we even start that this is not the entire chi-square table. I've just cut out just a little portion of it for you for illustrative purposes. If you go out in the real world and you do chi-square out after this class, you might find a chi-square value that's different from what, or a problem that requires the use of a critical value bigger than what's on this table. But what I've given you here is going to work for everything in this course and probably most things that you're going to do in real life. Okay, so let's look at the chi-square table. For every time you use a table, chi-square T or ANOVA, you're going to have a degrees of freedom and you're going to have a significance level. Every time you need a significance level, use 0.05. Just write that down, tattooed on your arm. It's never going to change for this course and for most statistical things that you do. The significance level of 0.05 is always what to use. And remember, Dan went over this in the lecture. That just means that we're going to be okay with a 5% chance that we're wrong. We're willing to risk about 5 times out of 100 being wrong. Now, the degrees of freedom is something we won't talk about here. It's just another simple calculation, generally some variation of n minus 1. So I won't tell you how to calculate that, but just know that you will calculate it, you'll have a DF, which is the degrees of freedom, and you'll have a significance level. So you'll come to your table, your chi-square table, you'll go first to the 0.05 column, and you'll go down the column until you get to the DF. So in this case, say we had a degrees of freedom of 2. We calculated degrees of freedom, it was 2. So we go down the 0.05 column until we get to 2, and go over that row until the 2 meet, until the DF2 row meets the 0.05 column. In this case, we would have a critical chi-square value of 5.991. This is the number that you would compare to your calculated chi-square number. In this, right now, we don't know what the calculated chi-square number is. We don't even know what chi-square is, but that doesn't matter. I just want you to understand that when we say compare your calculated value to your critical value, this is what we're talking about. We'll also always walk you through this. Every single time we'll pull up a table, we'll walk you through it, but this is just to give you a preview, to get you sort of comfortable with the mechanics before you dive in. Okay, so we've talked about the chi-square value. You go to the 0.05 column, you go to the correct degrees of freedom row, boom, there's your number. Let's move now to the T table. This is a tiny bit more complicated, but not that much more. So we're going to start with an example where we have a one-tailed hypothesis, and then we'll move on to the two-tailed situation in just a second. So in this example, say you have a one-tailed hypothesis and you had a degrees of freedom of 16. You calculated this through some formula that we give you. So there are 3 steps here. First, pick the right row, the one-tailed or the two-tailed row. And you'll see we've highlighted that first, the top row that says one-tailed. Then you've got to get the right column, the 0.05 column, right? So we go over just to the very first column, 0.05, and go down, 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 until you get to degrees of freedom as 16. And the number inside the chart where those 3 things converge, the one-tailed 0.05, DF equals 16, they all converge on the number 1.746. That is the critical t-value for a one-tailed test at the 0.05 significance level for a degrees of freedom of 16. Oh, that's a mouthful, but it all will make sense once we've gotten through the t-test module. But hopefully that gives you kind of a hint on how to use this t-table for a one-tailed test. Let's go back to it and I think you'll be able to sort of intuit how to use it for a two-tailed test, but let's just walk through it quickly. So instead of looking at the one-tailed row at the top of the table, we'll look at the two-tailed row. And remember, we always want the 0.05 significance level, so you have to pop over to that second column in this table, the second column with numbers, to the 0.05, and we'll use that same DF, degrees of freedom, of 16. So go second row, two-tailed, second column 0.05, down, down, down until you get to the degrees of freedom of 16. Boom, there's your critical value, 2.120. So when you have a two-tailed hypothesis and the degrees of freedom of 16 at the significance level of 0.05, your critical value is 2.120. You'll always compare the critical value to the calculated value. Again, we don't know what a t-test is. We don't know how to calculate it. We don't even know what it means. You'll worry about that in Module 5. Now let's move on to the third table. It works just the same. It's very similar to the chi-square table because we don't have to worry about the tail, the one-tailed or two-tailed hypothesis situation. Okay, so the one funky thing about the ANOVA table or the F table is we don't even have to look up the right significance level. This table is only for a 0.05 significance level. There's another table for a 0.10, another table for a 0.001. This is just for the 0.05 significance level. And the reason they have to have separate tables for each significance level is because there are 2 degrees of freedom. So if you had a column for degrees of freedom and a row for degrees of freedom, and then you also had to have a separate section for each each significance level, this table would quickly become 3-dimensional and we wouldn't even be able to talk about it. So they have to create a separate table for each significance level. So the ANOVA formula, when we look at the ANOVA table, when we look at it, we don't even need to worry about the 0.05. We just need to know 2 different degrees of freedom numbers, and those are just going to be 2 very simple formulas, just one number divided by another number, and boom, you'll have it. And so let's say, for argument's sake, that you've calculated that the DF upper, don't worry about what that means, it's just a number, is 3, and the DF lower is 12. All right, so you go over first to across the DF upper row until you get to 3, and go down, 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 just like you did before, until you get the degree of freedom lower of 12. They intersect at the number 3.49, and that's it. So it's just like we did in the first 2 tables. The critical value, in this case, the critical F value is 3.49. You'll compare that to your calculated F value. What's the F value? We don't know. We don't care. That's not what's important right now. You just need to take from this quick film how to use each one of these tables. If you don't feel like you have it down quite yet, you can watch this again, or just say, you know what, they're going to show me again when I get to each of these tests, and it might make a little bit more sense to you once you know what these calculated values are. But if at any point while you're going through the homework perhaps, or the practice problems, or even the lecture, and they say, wait, and we tell you to look at the critical value, you might say, wait, what is that? How do I get that? Come back to this lecture, hit play, walk through it again with me, and I think it'll be clear to you. So in summary, we have 3 test formulas that we're going to do, chi-square, T, and F. Each one of them is associated with a table. And I will tell you that each one of those tables was derived from a different sampling distribution. So we've talked about the normal distribution, that's basically a bell curve. The T distribution looks a little bit like that, and the chi-square and the F formula are a little bit lopsided. It doesn't matter how we got the shape of those, and it doesn't matter how the tables were pulled from those distributions to give these numbers. What's important is that we have to go to the correct table for each test. So look through this again if you need to, or just keep it in your back pocket for a tool as we move throughout the course.